for this one, I would work out all the asymptotes and the intercepts first, and then kind of use that to eliminate graphs. So let's see what we can figure out here. Our vertical asymptote is going to come from the zeros in the denominator. So let's go ahead and get that set equal to 0. And then if I factor this, I'm going to get x plus 3 quantity squared, or what multiplies to be 9 and adds to be 6, so 3 and 3, so I could write it x plus 3, which is the same thing as x plus 3 squared. And that equals 0, and so I know I have an asymptote at x equals -3, and then I know that the graph is going to, remember we have two choices. At an asymptote, they can either kind of go opposite directions, like one side goes down, one side goes up, or they can go the same direction, either up or down. And so in this case, because this is squared, it's going to be this one. If this had been to the first, it would be this one. So I know at -3, I'm going to have a vertical asymptote, and I'm going to have the graph heading off in the same direction. So it could be that one, could be that one, can't be that one because that's 3 and 3. So now I'm down to these two choices. If I find the y-intercept, I would just let the x equal 0, so I'd have 2 times 0 over, that would be over 9, so 0 over 9, and I get when x is 0, y is 0. Likewise, if I set the numerator to 0, because that would get me, actually set the numerator to 0. There we go, 0 equals 2x, solving that, x equals 0. So the x and y intercept are both the origin, which makes sense because it's the only point they can be both. So that didn't really get me anywhere because it crosses at 0, 0 on both those graphs. And then same kind of thing here when I say what's the horizontal asymptote. This would be small over big. Remember, if the degree of the numerator is smaller than the degree of the denominator, then that's going to make the horizontal asymptote, HAY equals 0. And that's, again, the same in both of these pictures. So now we're kind of at the point where we're like, how do I tell which one it is? So, let me make that small again. Not that small. So what I would do is, there we go, I would just use the test point. So I'm going to throw 1 into this original equation. If it comes out negative, then I know it's this first graph, and if it comes out positive, I know it's the second graph. So if I let go, y equals 2 times 1, 1 squared plus 6 times 1 plus 9, I get y equals 2 over 7 and 9, 16. So it looks like 1/8. And back here, for this one it would have been negative. For this one it's positive in just a little bit. And so we can see that when x was 1, y was 1/8, and that makes it the second graph. And so that's probably the easiest way to narrow it down between those two, is just grab a test point. Hopefully that helps.